Okay, welcome everyone back our lesson. This is the next part for the matrix computation, and this is a new lesson focused on the tensor products of the matrix. Actually, this one is the good part for the introduction to the quantum computing and programming. And today we will look more how we can, multiply the tensor products in the one matrix, and we will look more complicated matrix. Okay, so the previous we already learned how we can multiply the two vector, right? And two is very important. Two vector we need to have a number of column need to equal to the number of number of rows in the next. Yeah, we have this part. So if you want to multiply two vectors each other, so yeah, to make sure this kind of match, right? N and P may be equal N and P. So over here, we will look more about the more general. Yeah, more general. What about the is different? So how you can multiply? So over here, we need to transfer. Yeah, we need to transfer. For example, the A multiply B. So over here, we cannot multiply directly. So we can multiply with x the value, x the value in the vector A, and multiply with B. So multiply B, and we will explore for B the vector later. Yeah. So if you see over here, we have the total about the m multiply n, right? We have a dimension, m rows and n column. So we can multiply each element in this kind of matrix with B. So you can see this one. So after we multiply the value in the vector A, and we can see this kind of the full version for vector B, right? So you can see this one. And yes, on this guy base. So remember the last part. Yeah, last part we only if we have one we have C one TVS A, right? This so this one is going to you can CA. Yeah, CA. This is CA1 IGA1. Yeah, CA2. N, yeah, this one. So I mean, if you already have one constant and you have one vector, you can multiply, multiply with kind of vector. But over here we have a lot of this kind of children, children. We'll say this kind of parent and this kind of children, and we will explore. Check more about the more complicated after you multiply. Yeah, you see. From previous, I multiply this one, right? So after you multiply this guy value for each guy, right? So if you see, yeah, after you multiply, yeah, and you can see this we have this guy of the children, the vector. In the one this kind of parent, yeah, the parent, and the parent vector space is equal to this pi, yeah, to this guy, MP multiply NQ, yeah. Okay, so if you see previous one, so we have MN and PQ, right? So now after you multiply, you have a total about the C, yeah, MP and multiply the NQ. So yes, we can see this is how the example for this one is this is a 2, 3, okay, and this is kind of 2, 2, right? So the total we can say we have 2 multiply with 3, 2, right? So this one is 4 equal to 4 and 6, right? So you can see 4, right? 1, 2, 3, 4, right? And 6 1, 2, 3, 4, 5, 6, right? 6 column, yeah. So remember this formula, actually this kind of formula, remember this part, yeah. For this kind of element, so you can see with the children, yeah, the children, and multiply this one, yeah, and this one, and this one. So you can see actually equal to this part, okay? For the other is similar, yeah, so the other is similar. And here is we have this one is we have 3, 1, right? And over here we have 1, 2, right? So the final we have this guy of final we have 3 multi 1. This is 1, 2, right? So this is equal to the 3. Yeah, 3. 1, 2, 3, and 1, 2, right? So we have 3 rows and 2 column, yeah, 2 column. So you can calculate, and similar. This one is a kind of easy, yeah, easy. I think you got it, yeah. Actually, you only apply the formula, you can find the result. And here is similar, yeah. Actually, how you multiply this one is 1 is 3, right? And this is 1 is 2, right? So the final result, so I think we'll have 1 multi with 3 multiply 2 is 6, right? So you can calculate by yourself. This one we have 1 column, 1 rows, right? And 6 column. 1, 2, 3, 4, 5, 6, right? Yeah. So that's how calculate quickly, yeah. This is similar, yeah. We have this is 1, 3, and this one we have 2, 1, right? So the final result we have 2, 3, right? So 2 rows and 3 column. Yeah, you say 1, 2, 1, 2, 3, right? Yeah, so that's easy. Yeah. Okay, so this is the summary. So we have the tensor products, tensor, okay, tensor products. Tensor product of matrix, and how you calculate a matrix, two matrix together, a matrix, yeah, matrix. And this kind of matrix do not have the A, M and N, and multiply B is PQ, yeah, PQ. So this kind of the matrix doesn't have a kind of match the number of rows or number of columns. So we need to follow our new formula, tensor products. Yeah. Okay. Thank you everyone. Yeah.